Hi guys, today we're going to be reviewing Calculus Unit 2 for the AP exam. And in this unit, the main points of focus are rates of change, limit definition, basic rules, product rule, quotient rule, trig functions, tables, and graphs. So this unit's all about taking the derivative of functions. And basically what the derivative is just a rate of change, or in simpler terms, it's the slope of the function. So let's go down to this. So in this one, like, we're looking at this graph here, and if we were trying to figure out what the rate of change was, the rate of change is just the slope. So like, imagine it's the distance between here and here. What's the average rate of change? It's the slope between the two. And the derivative of a function is just as you get closer and closer, this value gets closer and closer to this, what is the change until it's like 1 over an infinitely small number, and then the distance between the two. And that will help you know what the rate of change is at a specific point. Okay, so let's get into how we would find this. So the first thing you need to know for the AP exam is the limit definition of derivative. So this is how you find it using limits, which we just learned in the previous unit. Okay, so let's plug this in and add an h variable to each x. Okay, so this is going to give us x plus h cubed plus 6x plus h, or on the outside, because it's x plus h, so each x is just an x plus h, and you're just plugging it in. So it's plus 6x plus h minus, this is our f of x, so x cubed plus 6x. This is all over h. So now when we FOIL this out, what this is going to look like is it's going to end up being 3x squared h plus 3x h squared plus h cubed plus 6h. And then we're going to divide by h. That will cancel this, one of these, this. And then that will end up giving you 3x squared plus 3x h plus h squared plus 6. Now, where the last part is the limit as x approaches 0 up here. So when h equals 0, that means that this h is no longer a thing. This h multiplies by 0, so you no longer have that, and you're left with 3x squared plus 6x, which will be your derivative. Okay, now let's try question B. So we're going to start at the top, so we have h squared plus 4 times x plus h minus 5x squared plus 4x over h. Now, I forgot to explain why this gives us the slope. And essentially what this is that h is an extremely small number. So limit as h approaches 0 is like almost 0, but not quite 0. So this will give us our function, which is f of x squared plus x, plus the tiny little number ahead of it, minus the original point of the function at that value, and then divided by h. So this is essentially our rate of change formula up here, except that h is a tiny number, and we're trying to find what the slope is over the small range. Okay, so now let's solve this. So that's going to end up being 5 times x squared plus xh 2xh plus h squared plus 4x plus 4h minus 5x squared plus 4x. We're going to just assume that's over h, so I don't have to keep track of all that. Times it by 4, distribute, so 5x squared minus 5x squared, these are going to cancel out. 10xh, is there any other xh's? So it'll be 10xh then we have 5h squared. Is there any other h squared? No, plus h squared plus 4x plus 4h. Okay, so it's going to be all over h, and now cancel out, cancel out, cancel out, and then what you are left with is you are left with 10x plus 5h plus 8xh plus 4. Okay, and then now as h approaches 0, this is going to approach 0, this is going to approach 0, and you're left with 10x plus 4. Okay, now like what I said before, the average rate is just this, and it's a pretty simple concept, so I'm only going to do one question, and it's something you understand before. So the average rate of this is asking for the slope over this interval. So it's basically if someone asked you the derivative of this over this interval, this is how you'd find it. And it's just f of b minus f of a over b minus a. So you just plug these values in. So when it's 1, it's going to be 9 plus 5, which is going to be 14, which will be our f of a. When you plug in 3, it's going to be 27 plus 5, which is 32, all over 3 minus 1, which will be 6, 8, 18 over 2, which will equal 9. And that will be our average rate of change over that interval. So now let's look at this last one. What is the limit definition of this? So this is kind of like the inverse of what we were doing up here, where we're now trying to figure out what the original equation was. So we know the basic setup here is going to look like this up here. Okay, so that just gives us, basically, we know it's going to be tan. So the x value here is going to be equal to 4 because you look at the inside of this, and that will tell you what the x value is, like where the location is. Because if it's 4, it's going to be the location. And then now we know it's tan 2 of x. Oh, okay, wait. So so this will tell us the original equation plus h. So the original equation is tan 2x. Now we need to solve because we know this is tan 4. So we can just get rid of the tans, and it's 4 divided by 2, so the x value is 2. And that will give us minus tan 2 times 2, so minus tan 4. Now let's do the same thing for this one. And while this might look scary at first, it's actually not that bad because you just need to expand everything out. So ln with the division is the same as ln 6 plus h minus ln 6. And then that 1 over h distributes to h. Now it looks really familiar, doesn't it? So we know that this is going to be our final x value once we plug it in here. Okay, and we know that this is plus h. So it's really just our equation is ln x, and the x value is 6. Okay, simple enough. Now I'm going to go over basic derivatives so you don't have to do limit definition for every single time you want to figure it out. And this is just a rule where it is the x value, a, and the power. You're going to put the power times a and then minus 1. So what this looks like down here will be the 2 times the 5 equals 10x. Now 2 minus 1 is 1. Just 10 to the x. Okay, so that's our derivative for that. Now we'll take it here. This is x to the 1 times 2 is just going to be 2. And then x to the 0, like anything, is just 0. So now we're left with 2. And the constant, once you have a constant, it's already to the power of 0. By the way, the 0 is to the 1, that's what I meant. It's already to the 0. and then you minus the 1, it goes to nothing. So you just ignore this, and your final derivative is 2. Okay, now the square root one, that's 1/2. So you're left with 6 times x to the 1/2 plus 2. We know the constant's going to go away and be nothing. So now let's multiply it. So now you're left with 3x to the 1/2 minus 1, or negative 1/2, which will leave us with, put it on the bottom, negative 1/2. Okay, now let's look at D. D is one of those ones where you have to know it just on your own, because 1 over x to the negative 1, negative 1, yeah, sorry, this is the wrong one I was thinking of. 1 over x to the 1, you bring it up to the top, negative 1, so x to the negative 1 times negative 1, then that goes minus 1, x squared, and you're left with negative 1 over x squared. Now we do the same thing. Now it's just x to the 1/2. You bring that up, it's negative 1/2. And then you end up with negative 1/2 times 1 over x to the 3 over 2. Or you get negative 1 over 2x to the 3 over 2. Last one, this is just going to end up being, you can deduct from these two problems that this is just going to be negative 2 over x cubed. Okay, and now this is really, like, whenever it's plus, you can just chain them all together. You take each one individually and then add them together. So this is going to be really quick. It's going to be times with 5, so 50x to the 4th plus 1/3, 7 over 3, x to the negative, so x is going to be 2/3 on the bottom, then 9x squared plus 1/2 times 2 is nothing, plus x, and then constant. And this will be your final derivative. Okay, and then the last one you need to know is that e to the x, the derivative of e to the x is just e to the x. There's nothing special about it. It's just, that's something that you have to know, because it's just, that's how it is. Okay, next we're going to look at the multiplication rule, which is basically, or quotient rule, but it's basically you have two functions and they're multiplied each other. Like, so if we look at our first example, you have 3x minus 2x squared times 5 plus 4x. And what you're going to do is you take the derivative of the first one, times it by the original function of the second one, then you add it to the original f of x times the derivative. So let's see what it looks like in practice. So we're going to call this f of x. We're going to call this g of x. Okay, so f prime of x and g prime of x is what we need to figure out. F prime of x is simply going to be 3 minus 4x, and g prime of x is just going to be 4. Okay, so now we can solve in and just plug it into this. So f prime of x is 3 minus 4x times our g of x, 5 plus 4x. Okay, take all that, add it to our original f of x, 3x minus 2x squared, times g prime of x, which is 4. Okay, and from there we just solve. Okay, so this is going to be, sorry, I need to add the parentheses so it's easier. So 3 times 5 is 15, 3 times 4x plus 12x minus 20x minus 16x squared plus 12x minus 8x squared. Okay, so 15 is by itself. Now let's look at the x's. 12x plus 12x is 24x minus 20x is going to be 4x, and then 16x squared minus that is going to end up giving us 24x squared. And that will be your final answer. Okay. Now let's look at this one a little bit more interesting. This will be our f of x. This will be our g of x. Now f prime of x is what we need to find, and same with g prime of x. That will equal, okay, this is going to equal 22x. This is going to equal, you bring x up to the front, so 5 to the power of, I think this is meant to be x minus 4. Okay, x minus 4 brought up to the top to the negative 1. You'll end up using the chain rule, but it doesn't matter. Okay, so it's going to end up being negative 5 over x minus 4 squared. Okay, now let's plug that in. So we'll take our original, or we'll take our f prime of x, g of x, and we'll add it to our g prime of x, which is negative 5 over 4 squared, which will be multiplied by our original f of x. Okay, and then we're going to left with, it's going to be a large number. It's going to be 110x over x minus 4 plus negative 55x squared minus 10 over x minus 4 squared. Now we can times it by each by both sides, x minus 4, to make them so they're the same. And then you're going to get 110x squared minus 440x over x minus 4 squared plus 55x squared minus 10 over x minus 4 squared. Combined terms, you will end up getting 165x squared minus 440x minus 10 over x minus 4 squared. Okay, now let's go over the product rule, or how to divide. So this is very similar to the last one, except now you're just minusing and you are dividing by g of x squared. So let's look at this. Let's set the top one up is f of x. The bottom one is g of x. And now let's get our f of prime x, our g of prime x. Okay, f of prime x is just going to be 5. G of prime x is going to be 2x. Okay, so now we need to take f of prime x, 5, times g of x, x squared minus 1. Minus that by g prime squared, so we have 2x times the original f of x all over x squared minus 1 squared. Okay, so let's get this out. This would be 5x squared minus 5 minus 10x squared plus, or I guess minus 2x 4x. Okay, so now we're left with negative 5x squared minus 4x minus 5 all over, and probably just leave it as x squared minus 1 squared. Okay, and that will be your final answer for the derivative. Okay, now let's look at a second one, e to the x. Well, this will be our f of x. This will be our g of x. So we know f prime of x is just going to be e of x, and g prime of x is just going to equal 2x. So let's solve this out. We know that it's going to be e to the x times 1 plus x squared then we are also going to subtract that from e to the x times 2x. Okay, so e to the x plus x squared e to the x minus e to the x, or 2x e to the x. Okay, and that's all you can do. And then you just need to divide that by 1 plus x squared squared. That's about as far as you can take it. Okay, lastly, let's look at this one. So for this one, it's actually going to be separated. So what it's going to need to be is you're going to need to make this, by rewriting it, you can make it into that times 2x squared. So you're going to want to take the product rule of this and then multiply it by this. Okay, so this will be our f of x, this will be our g of x, then inside of this will be our f, actually let's make it easier, remember, we'll call it h of x and j of x, these inside functions. So first let's figure out what this is. So that's going to end up being h prime of x, j prime of x is equal to 10x plus 4, 14x. Okay, so using the product rule, our f of x is going to end up equaling, it's going to be, it's f prime first, so 10x plus 4 times g of x, which is 7x squared, minus 14x times 5x squared plus 4x. Okay, let's figure this out before we divide it. We all know it's going to be divided by 7x squared. So let's just go ahead and we'll do that. It's going to end up being $70x cubed plus 28x squared minus 14 times 5 is 50, 20, 70x cubed plus 14, 40, 56x squared. Okay, so these cancel out and you're left with 56 plus 28 is going to be 84x squared over 7x squared. Okay, now let's times that by 2x squared. Okay, we're approaching the end. Okay, so the original f of x is that, then f prime of x equals that. G prime is going to be 4x. Okay, so let's just erase this to give us more space. Okay, so first we're going to take this, our f prime of x, we're going to times this by the regular, and then we're going to add it to 5x squared plus 4x over 7x squared times 4x. And that'll be your answer. I mean, you can FOIL it out more, but really this is all you need. That's your answer. Okay, one of our final things we need to know in this unit is the derivative of trig functions. So for this, each one of these, you're basically just going to be looking at the opposite of what it is. So cosine x is going to end up being negative sine x. Sine x is going to be cosine x. Negative sine x is going to be negative cosine x. Negative cosine x will go back to sine x. And this is because if you look at it on a graph, sine x will go like that. Cosine x is going to go like that. So it's going to be the opposite, which will give you the derivative, or the slope Because look, as the slope goes down here, then, or sorry, because this is sine. So as it goes up here, the slope is getting slowly less and less and approaching 0. It approaches 0 right as this gets to the top. Then it starts coming back up, but it's negative, and then it reaches 0. So that's how those work. Now tan is going to be secant x squared. Secant x is going to be secant tan x. Secant x tan x. Cosecant is going to be negative cosecant x cotan x. And cotan x is going to be cotan secant x. And these are just ones that you kind of have to memorize, and they will get used on the AP exam. Lastly, let's look at table functions. So like we said before, the table is just the slope at the given spot. So if we're looking for the f prime of 3, the slope here is just going to be rise over run. So it's up 8 over 3. And then at 8, it's going to be 5, 3 over 9, or 9 over 3, which is equal to 3. Now, the table can get a lot more tricky, but basically all you need to know is that you're trying to find the slope at the given point, and if it gives you the slope, then you're trying to find the point by just adding up from the past values. Okay, if you guys enjoyed this, please like, subscribe, and give me some feedback in the comments.